So today we will try to cover eigenvalues and eigenvector, and we will also try to solve all the questions of GATE regarding this topic. And I will try to show you some shortcut tricks so that will be helpful for you. Okay, shall we start?
Yeah, ma'am.
Okay, so be interactive. Okay. Okay. So we have already covered the matrix algebra and system of linear equations. There were around 22 to 23 questions which has been asked in GATE mechanical. We have already solved all those questions. In my next session, I will try to provide you questions which has been asked in other branches like EC and CSE regarding this topic. Today we will see eigenvalues and eigenvectors and we will solve the questions. So uh, before the class, I assume that you have already learned all these things. I'll just try to brush up all your previously learned concepts, and I will try to give you some new tricks that will be helpful for you in the examination. So, what are the eigenvalues? Eigenvalues are the roots of the characteristic equation A minus lambda is equals to 0. What are the eigenvectors? To each eigenvalue lambda, if there exists a non-zero vector x, such as ax is equals to lambda x, then x is called eigenvector. So this is just the definition. We'll see the example, how to calculate eigenvalues and eigenvectors. So for eigenvalues and eigenvectors, every time in GATE they asked almost 1 to 2 questions. Every year they ask. And the questions are easy. So let's start with the 2 cross 2 matrix. Suppose A is a 2 cross 2 matrix, 4 2 2 4, and we are being asked to calculate the eigenvalue and eigenvector. So how to calculate eigenvalue and eigenvector for a 2 cross 2? You have to write the characteristic question. So we can write A minus lambda is equals to 0. So A minus lambda, how will you write that? Just minus lambda from the diagonal elements is equals to 0. This is your characteristic question. And solve this. Take a determinant minus 4 is equals to 0. When you solve this equation, lambda values will be 2, 6. This is your eigenvalues. Now, for every eigenvalue lambda, there will be exist a non-zero vector, which will be called as eigenvector. So, what are the applications of eigenvalues and eigenvector? So, you all are in mechanical. So, when we write a stress tensor, a 3 cross 3 matrix. So, when you calculate the eigenvalues or eigenvectors of a 3 cross 3 stress vector, so those eigenvalues and eigenvectors are the principal stress value and principal direction. Okay, so this is the application in your field of eigenvalues and eigenvectors. What will the maximum value of the stress, that is principal stress, that will define by the eigenvalue of that matrix. Okay, so how we will calculate the eigenvectors? We have two eigenvalues, 2, 6. So firstly, we will calculate for lambda is equals to 2. So consider, please everyone try to join at 6. Okay, sharp 6 is equals to 0. So firstly, you put the lambda is equals to 2 in this matrix, 4 minus lambda. This matrix put lambda is equals to 2. So our new matrix will be this x1, x2. So this trick is for only 2 cross 2 matrix for calculating eigenvector. Okay. So what you can do, you can do one row operation, R2 minus R1, R2 is equals to, so it will be 2, 2, 0, 0. In write the equations, that will be 2x1 plus 2x2 is equals to 0. 2x1 is equals to minus 2x2. You cross multiply x1 divided by minus 2, x2 divided by 2. So x1 by minus 1 is equals to x2 divided by 1. So your eigenvectors from there will be x1, x2, sorry, x1, x2 is equals to minus 1 and 1. This is how you will calculate a eigenvector for 2 cross 2 matrix. Now I want you to calculate for lambda is equals to 6. Please calculate. Calculate for lambda is equals to 6. Anyone got the answer?
1 1.
Okay. Shubha, 1 Vikas, 1. Okay. Correct. Very good. Is anyone there who is not able to calculate? Prashant. Next. Is there anyone? Please use the chat box. Hari, yes. Correct. Everyone can solve this, right? Okay. So what we are doing, we are calculating the eigenvectors. So you understood how we calculated the eigenvalues, right?
Yeah.
Okay. So for that, for every eigenvalues, there will be one non-zero vector that will be called eigenvector. So how we calculate the eigenvector? Uh, this equation, in this equation, your x will be your eigenvector. So what we did, firstly we write this matrix. So here you have already written a minus lambda a matrix, which was 4 minus lambda 2, 2, 4 minus lambda. So what you have to do, firstly you have to put the value of lambda, which was 2 here. So we did that. Then after that you multiply. The way you multiply the uh, matrix, you multiply. Then you'll get this equation. Okay, what we are doing here, we are finding this x. This is our unknown vector. This is your matrix. This is your eigenvalue. This is your identity matrix. This is your null matrix. Okay, so you have to find this eigenvector, unknown vector x. So after that, what you did, I converted this. Suppose, see, in a matrix, if you're doing any row operation or column operation, your determinant value, your eigenvalue, and your eigenvector value will never change. So what I did one row operation. Now my matrix is like this. Okay. Then I simply multiplied and I got this equation, this one equation. From that equation, uh, I got the like kind of ratio of x1, x2. So what value will be in x1 and what will be in the x2. So those values will be called as eigenvector. Okay. Same thing I asked you to do for lambda is equals to 6. Did you get some idea?
Yes, ma'am.
Okay. So if you'll calculate for lambda is equals to 6, your eigenvector will be 1, 1. Okay. You small thing.
Excuse me, ma'am.
Yes.
I have a doubt.
Yes.
Always we get infinite solutions out of this equation.
Sorry.
Do we always get infinite number of solutions? Like we get the x1 and x2 in kind of a ratio, right?
Okay.
So which means that we are getting infinite solutions from this.
It's the vector. Suppose. Uh, just a second. Suppose this is your ij. So this vector is suppose this is your eigenvector. Okay. So this is a vector. In this direction, you can do any kind of linear transformation. Okay. That will also be your eigenvector. So suppose we got -1 and 1. We can write minus k1. Suppose this is 1, so we can write minus k and k. So for any value of k, you can stretch this vector to any length. That will be your eigenvector. That is why we are having infinite solutions. You understood?
Yeah, got it.
Okay. And how much you can stretch, that is called your eigenvalues. Suppose you have some square. Okay. You're doing linear transformation. That will be your matrix. How much can you stretch this matrix maximum value? That is your eigenvalue. In which direction? So that it will not change. So will its determinant will not change. Its principal values will not change. That is called your eigenvalue. And in what direction you can stretch? That is called your eigenvalue. You have studied that stress tensor also. Na? One of the example of this is stress tensor. So when you calculate the eigenvalue of your stress tensors, that will call principal stress and principal vectors. That is the maximum stress. You understood? At some plane. That is why we get infinity solutions. Okay?
Okay.
Okay. So, uh, do you all know about linearly dependent and independent vectors? If you do, please write in the chat box. If anyone doesn't, I will tell. Okay. So two vectors x1 and x2 are said to be linearly dependent if One can be expressed as a scalar multiple of other. Okay, suppose x1 can be written as 2x2. So x1 is linearly dependent. Otherwise, it will called as linearly independent. So how we check if a vector is linearly dependent or independent vectors? So suppose they gave you two, three vectors. This vector you have k1, k2, k3, a1, a2, a3, b1, b2, bt3, and they ask check if these vectors are linearly independent or linearly dependent. So there are two steps to check if a vector is linearly independent or linearly dependent. First, if determinant of the matrix, you make a matrix out of these three, and if the determinant of that matrix does not is equals to 0, or rank of that matrix is equals to the order, then this set of vectors will be called linearly independent. Okay. Second step, if your determinant is 0, please turn off your mic. If determinant is 0 or your rank of the matrix is less than n, then this will be called as linearly dependent vector. We'll see by one example. Turn off your mic, please. I'm giving you one vector 1 0 0, another vector 0 1 0, and another vector 2 3 0. Now please check if these vectors are linearly dependent or linearly independent. Please turn off your mic. So check if it is linearly independent or linearly dependent. Please turn off your mic. Solve it. I actually don't know how to use something. Suppose that option is available in Google Meet. Vinithana, please turn off your mic if you are there. Dependent. Okay. Correct. Vinithana, please turn off your mic. And she joining like dependent. Anshu, correct. Aviti, correct. I don't know actually how to remove words. Dependent.
Ma'am, there are three options, ma'am. About the profile, ma'am. There you can mute her, ma'am, or remove her, ma'am. Beside the profile, there is three options, ma'am. Like a column of three dots are there, ma'am. Only host can mute her or remove her, ma'am.
Okay, thank you. So you all know how to solve this question, or if anyone is not able to question, we'll solve this question here. Okay. I will solve the question. So what I told you, what is linearly independent, what is linearly dependent. So how we check? Firstly, what you have to do, whatever the vectors are given, firstly you have to make the matrix and get the determinant. So we have three vectors here. We will make the determinant. Matrix. So if you will calculate the determinant of this matrix, that will come as 0. So in our two steps, if your determinant is coming 0 or your rank of the matrix less than the order, then your vectors are linearly dependent. So that was a very simple question because your determinant is coming 0. So that will be linearly dependent question. Any doubts?
No, ma'am.
Okay, one more I'm giving.
Do we need to check the rank as well of the matrix?
No. I've written or. Anything will be okay. Okay. Sometimes they will
All
give
right.
you 5 vectors or 6 vectors. 6 cross 6, 7 cross 7. So in that time, it is not easy to get the determinant. Okay. That time, what you do, rank is easy to calculate than determinant. That I feel. So that time you calculate the rank. Okay. When your matrix is bigger, when your matrix is smaller, 2 cross 2, 3 cross 3, you can easily calculate the determinant. That time you just take the determinant. Okay.
Yes, ma'am.
When the determinant is 0, when one row is 0. When it will be 0, when the one is scalar multiple of other, then you can subtract and you can make one row easily 0. That is the definition of linearly dependent. Understood?
Ma'am,
Yes, ma'am. Got it.
Sorry?
how to understand the scalar product of that matrix?
Uh, so you have given the vectors. Okay. How we represent that I told you. Scalar product like x1 can be any kind. X1 is a vector, okay. It's not a value. X1 can be 2x2 something or some value in any three dimensions. Here you may feel that if it is 1000 and it is 2000, so they are linearly dependent. Then how these are linearly dependent? But this is because we are calculating for different eigenvalues. These vectors are for different values. Okay.
Okay, ma'am. Thank you.
So since we are looking at vectors, I'll tell you a few smaller terms like orthogonal vectors. A vector is called, or two vectors x1 and x2 is called orthogonal vectors is x1 transpose multiplied by x2 is equals to 0. Then they will call orthogonal vectors. Suppose in exam sometimes, suppose they give you two vectors x1, x2. They'll ask if they are orthogonal or not. So this is your formula. Okay. Now we'll go again to eigenvalues and eigenvectors. So we'll read about the properties because most of the questions are based on the properties of eigenvalues and eigenvectors. In exam, they will never ask you to calculate the eigenvectors of a 3 cross 3 because it will be very lengthy. I will teach you also how to calculate for a 3 cross 3, but it is not important. What is important is properties. Properties you have to learn. And for that, we have to practice questions. As many as questions you will practice, those properties will be already remembered by you. So what is the first property? Is the eigenvalues corresponding to the distinct eigenvalues of a real symmetric matrix are always orthogonal. What does that mean? Suppose we take a 2 cross 2 matrix 4, 2, 2, 4. It is a real and symmetric matrix. So the eigenvalues will calculate, if you will calculate the eigenvalues, it will come something like 2, 6. Okay. So what they are saying that the eigenvectors, sorry, this will be eigenvectors. The eigenvectors corresponding to the distinct eigenvalues of a real symmetric matrix are always orthogonal. What is the condition for orthogonal? Okay, so firstly, you just tell me the eigenvalue, eigenvectors for lambda is equals to 2. Calculate. What will the eigenvector for lambda is equals to 2? 1 minus 1. Okay. Okay, correct. For lambda is equals to 6. 1, 1. Correct. Is there any problem with anyone?
No.
Okay. So this is your x1. This is your x2. If you multiply the if you firstly transpose, this will be x1 transpose, and if you multiply both, it will come as 0. So the eigenvectors corresponding to the distinct eigenvalues of a real symmetric matrix are always orthogonal. Then if all leading minors of a real symmetric matrix are positive, then all its eigenvectors are positive. This also we will see by an example. Suppose there is one 2 cross 2 real and symmetric matrix. Okay. So calculate the eigenvalue for this. Everyone please calculate. The equation will be form something like this. So lambda will be a fraction 5.3 and 1.69, which is positive because your leading minors, all your leading minors of the symmetric will be positive. So your eigenvectors will also be positive. Okay, one more property. Eigenvalues corresponding to the distinct eigenvalues of any square matrix are always linearly independent. Again, I have written eigenvalues. This will be eigenvectors. So this is very important and favorite for the gate. What is this saying? The eigenvector corresponding to the distinct eigenvalues of any square matrix are always linearly independent. Suppose we will take again one 2 cross 2 matrix. Yeah, I'm showing you slide because I don't know if I can share you this PPT. So it is better if you can take the screenshots. Sooner we'll be able to share you these notes, but before that what I suggest, if it is better if you can take the screenshots. Okay.
Excuse me.
Yes.
Will you be able to help us with the previous class PPTs at the end of this class for taking the screenshot?
Yeah, at the end of the session we can do that.
Thank you.
Yeah. Okay. So we'll again take a 2 cross 2 matrix. If you solve this, your eigen will be value will be lambda 1 is equals to 1, lambda 2 will be 4. Again, you'll find the eigenvectors. It will become as 1 minus 1, 2, 1. Okay, I have shared one Google Drive link, but NPTEL is not still asked us to upload the notes. So if they are not uploading on the portal, then I will share that Google Drive link with you, and you can get the PPT from them. So if you there are two vectors, check if these two vectors are linearly independent or not. Okay, Anshul, correct. Nishu, correct. Shubha, correct. Okay. So this property is also we have seen by an example. Next property is the eigenvectors corresponding to the repeated eigenvalues of any square matrix may be linearly independent or may be linearly dependent. So how we check if this is linearly independent or linearly dependent? So in such case, when there is repeated eigenvalues of any square matrix, so what you do? You will calculate the rank of this matrix and the number of eigenvectors which are independent will be order or column or variables. This is n minus rank of A minus lambda matrix. Okay, we will solve the questions on these properties. Then it will be better for you to understand. For now, just see all these properties. After some time, we'll start solving the questions. So one more term is there, algebraic multiplicity of an eigenvalue. So number of times an eigenvalue is repeated is called algebraic multiplicity. Suppose there is a 3 cross 3 matrix and your eigenvalues are 2, 2, 3. So your algebraic multiplicity will be 2. Suppose it was 2, 2, 2, then it would be 3. Okay. What is the geometric multiplicity of an eigenvalue? The number of linearly independent eigenvectors of a repeated eigenvalue. Okay, this we will understand by an example. Suppose we are taking a 3 cross 3 matrix. Please calculate the eigenvalues for this matrix. What are the values for lambda? Will you share the drive video? I will share after the class. Okay, okay, I will share.
मैम आपकी आवाज सही से नहीं आ रही।
Okay. Is it for everyone else? Anshul correct. Shubha correct. Gautam correct. Is my voice is okay? I will share the drive link after the session. Okay. So lambda values are 2, 2, 2. So here, what will be your algebraic multiplicity? Can anyone tell? Is there any problem with my voice? Okay, okay. Give me a minute. Is it audible now?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. If you'll again lose the connection, please let me know, okay? Okay, thank you. Okay, then we solved this matrix and the eigenvalues for this matrix is 2, 2, 2. So can you tell the algebraic multiplicity? 3, correct. Because Anshul correct. Can you also calculate the eigenvectors? Calculate 0, 0, 0. Anyone else?
Ma'am, if our eigenvalue come 2 to 3, then what is algebraic multiplicity?
It will be 2. What is algebraic multiplicity of an eigenvalue? The number of times an eigenvalue is repeated. What will, suppose you're asking this. So they will ask for this eigenvalue. What will be the algebraic multiplicity? Here I asked what will the algebraic multiplicity for lambda is equals to 2. That is 3.
Okay, ma'am.
Okay, I will share.
Then is there a way to check the orthogonality of three vectors?
If they are orthogonal or not, it is for 2 cross 2 only. How can you measure if a matrix is 3 cross 3? Suppose you are having 3 vectors. Suppose you just imagine what is an orthogonal. Okay, so that is possible for 2 cross 2 only, na? If we'll go in more dimension, it is not possible for orthogonal.
Okay.
Okay. Okay.
In that
This
case,
is
we'll
a
compare between any two, right?
yes, yes. So what are we going? I will solve this because this is a different kind of question. Suppose this kind of matrix is given or identity matrix is given. So how will you calculate the eigenvectors? We will put the values and it will be null matrix. Okay. So from here, we calculate free variables. Whenever you see that there is one row, two row, which is 0, now you are not able to calculate x1, x2, x3 because there is no equation. You calculate first how many there will be the free variables. So what are the free variables? Number of columns or variables minus rank of this matrix. Rank of this matrix will be, tell me. Yeah, eigenvector is any non-zero vector. Yes. So whoever got 0, 0, 0, your answer is not correct. We are calculating eigenvector. Wait, it is not the answer. What we are going, firstly, if your matrix is looking like that and you are not able to calculate x1, x2, x3, this procedure you have to follow. So whoever got 0, 0, 0, your answer is not correct. You tell me the rank of this matrix. 0, correct. So your free variables are 3. So what will we do? We'll assume 3 free variables. x1 is equals to k1, x2 is equals to k2, x3 is equals to k3. These are your 3 free variables. Now we will try to write x1, x2 and x3. So your eigenvectors will be x1, x2, x3 are k1, k2, k3. Okay. We'll write it here. x1, x2, x3 will be k1, k2, k3. And the way you can write this 1, 0, 0, k1, so k1 will be here, plus k2 multiplied by 0, 1, 0, plus k3 multiplied by 0, 0, 1. Can we write this like this?
Yeah, ma'am.
Okay, everyone understood?
From the previous, from the Eisenhower of previous match.
Okay. So from here, you can get your 3 eigenvectors. So your eigenvectors will be 1, 0, 0, 0, 1, 0, and 0, 0, 1. These are your 3 eigenvectors. Now tell me if these 3 eigenvectors are linearly independent or linearly dependent.
Independent.
Okay, independent. You can see this will be an identity matrix and the determinant of an identity matrix is 1, which is not is equals to 0. That means they are linearly independent. Okay, I hope everyone understood.
Kindly repeat this part where after we got 0, 0, 0.
Okay, when you got 0, 0, 0, like there are less number of equation. I hope that you know how to calculate eigenvectors for 3 cross 3. Okay, so suppose for calculating 3 unknowns you need 3 equations, but this is a null matrix. You got a null matrix at the end, so you won't be able to calculate the your x1, x2, x3. In that case, what you do? Firstly, you check how many free variables are there. Okay, the formula for free variables are number of unknowns or number of columns minus rank of that matrix. So your rank was 0, number of non-zero rows are 0. So your rank are 0, number of variables are 0. So from here your free variable is 3. Suppose your free variable came 2. So here you will just assume x1 is equals to k1, x2 is equals to k2 and x3 is 0. Okay. Suppose it came 1. So what you have to assume that x1 is equals to k1 and x2, x3 is 0. First you have to calculate free variable, then you will assume k1, k2, k3 and then you will try to write your values in the form of k1, k2, k3. So these vectors that you will get is called your eigenvectors. Sorry, eigenvectors. Understood?
Yes, please.
Okay, any doubts in this? Okay, I assume no doubts.
So if we get two number of free variables, which means we'll assume k1 and k2, and other one will be 0.
0, yes.
Okay.
You have to calculate how many variables are free. Okay. There are some small properties, but they are important. Like sum of eigenvalues is the trace of the matrix. Everyone knows what is the trace of the matrix?
Sum of the diagonal elements.
Yeah, correct. Everyone know. Okay. Then the product of eigenvalues is the trace of the matrix. Then the eigenvalue of A and A transpose are same. Eigenvectors of A and A transpose are not same. Okay. Eigenvalues, why is it not same? Can anyone tell?
Yeah, ma'am. Because
Yes.
A tends to would be opposite, like row and column would be different.
Yeah,
So there.
correct. Trace of the matrix is nothing but summation of the diagonal elements. So what will be the trace here? Who asked me this question? Frederick Naveen. Tell me, what is the trace? Shubha, correct. The summation of the diagonal elements is your trace. Okay. So where were we? Eigenvectors. Yeah, you were right. Because when we are taking transpose, what we are doing? We are changing the direction of your matrix. And if you are changing the direction, your vector will be changed. Your value will be the same, but your vector will be changed. That is why it is not same. So you were correct. So eigenvalues of a triangular matrix or diagonal matrix are its leading elements. Okay. If lambda is eigenvalue of matrix A, then for A square it is lambda square. For A to the power m, it will be lambda to the power m. For A inverse, it will be 1 by lambda. For adjoint A, it will be determinant of A divided by lambda. Okay, these are small properties you should learn. Learn by your heart. As much as you practice, you will learn these things.
Ma'am, the product of eigenvalues, how can it be equal to the trace of the?
Sorry. That will be the determinant. Thank you. Product of the eigenvalues will be the determinant of the matrix. Okay. If uh, the eigenvalue of your matrix A is lambda, so for k lambda, your eigenvalue will be k lambda. For A plus ki, your eigenvalue will be lambda plus k, where k is scalar. For A minus ki, your eigenvalue will be lambda minus k. For the equation A square plus ca plus di, your eigenvalue will be lambda square plus ca plus d. Then the eigenvectors of A A inverse, adjoint A square, A cube, A4 are always same. Okay. In a square matrix, if n rows are identical, then n minus 1 eigenvalues will be 0. This is also an important property. We'll do question on this property, then you will understand. Then some small properties like eigenvalues of real symmetric and Hermitian matrices are real. Uh, in next slides, we will see what are Hermitian matrices. Then eigenvalue of a real skew symmetric and skew Hermitian matrix are either pure imaginary or zero. Sometimes they just simply ask 1 mark question on these properties. Suppose they are giving a real symmetric matrix and then they will ask if eigenvalues are real or imaginary, if they are pure imaginary or zero. Then eigenvalues of unitary and orthogonal matrices are of unit modulus. Okay. Then these properties I have already told. Product of eigenvalues determinant of A. Maximum number of distinct eigenvalues of A is equals to size of A. If A and B are two matrices of same order, then eigenvalues of AB will be equal to eigenvalues of BA. Okay, now we will solve some questions. So this was a question that was asked in GATE. They have given you this matrix. They are asking you what will be the product of non-zero eigenvalues of this matrix. Your options are A 0, B 2, C 3 and D 6. Okay, try to solve this question. Give it a try. Whatever the properties that we have seen, it is based on that. Okay. Whenever I give a question, just read that question so many times. Always in GATE, the first thing that you do, read that question twice or thrice. Sometimes what we do in hurry, we leave lot of things. The question is very easy, but just because we are not reading it, we feel it is difficult. Okay. Try to solve this question.
Ma'am, that would be 6.
Okay, we'll see that. I just want to know how you are getting 0. 3 of you written 0. Tell me how you got 0. It could be right also. Just tell me how you get 0.
Calculating determinant, madam.
Okay. So they are asking the product of non-zero eigenvalue, right? So if the eigenvalues are non-zero, so their product will never be 0. So how are you getting it? That's why I told you to read the question. First option is already eliminated. After reading the question, you understood what they are asking. They are asking the product of non-zero eigenvalues of the matrix. If the values are already non-zero, so your answer will not be 0. Understood?
It seems none of the option is correct.
Sorry?
I think no option is correct.
Okay.
No, the answer will be 6.
We will add one more option. None of these. Answer is 6. All are writing is 6 and telling me 6. You are correct. Can you tell me how you calculate it?
Yeah, ma'am.
Yes.
Because A lambda I, then firstly, I have done the row operation R1 plus R5. Then the second would be the row operation. Second times I did R2 plus R3 and R4. And then lambda equal to lambda 2 or lambda 3, then the product of eigenvalue would be 2 into 3 equal to 6.
Okay. Okay. Everyone followed the same method? Or is there any other method?
However, the process is with lengthy, ma'am. Time consuming. If
It
there
will be
is
very time consuming.
yes, ma'am.
Any other trick? Any other way of solving this question?
Yeah, that's what I am asking to
I
you.
will
That
tell
if
you. I will tell you. That's why I'm here.
Ma'am, hello.
Yes.
Yeah, the trace of the matrix will be the sum of the eigenvalues,
Correct.
and the number of eigenvalues which will be zero will be n minus one. So we have four identical eigenvalues. Sorry, four identical rows, and so four eigenvalues will be zero, and sorry, three eigenvalues will be zero, and according to the size of the matrix, which is 5, so two we are having non-zero eigenvalues, and the sum of the trace is 5, so we can guess it can be 3 and 2.
Yeah, correct. Very good. So what we are doing here, what he did, we have seen one property in a square matrix. If n rows are identical, then n minus 1 eigenvalues will be 0. So this is a 5 cross 5 matrix. So we were getting 5 eigenvalues. Okay. But here you can see these two rows are identical. So these two rows were giving us two eigenvalues, but since they are identical, so our eigenvalues will be reduced by 1, which is 1. So from these two rows, you will get just one eigenvalues. Then again, these three are also identical. So they were giving you three eigenvalues. But since they are identical, now they will give you two eigenvalues. So what now we have?
Ma'am, you are not audible.
Am I not audible?
Yeah, you give.
Audible.
Okay, I assume I'm audible for everyone else. Okay. So what we are now, we have three eigenvalues which are 0. So you have two eigenvalues. Okay. So trace is the summation of your eigenvalues. What is your trace here? 5. And your so now here you can just guess lambda 1 plus lambda 2 is equals to 5. In the options you can see there is only one option that can satisfy your condition, because if the summation is 5, then definitely its multiplication will be greater than 5. Okay, so your answer will be 6.
And we are having three non-zero eigenvalues, no?
See, there are three columns. There are three columns. Okay, so number of 0 eigenvalues will be number of identical rows minus 1. So there are three identical rows, 3 minus 1, that will be 2. So here you will get two 0 values. And here also you will get 1 0 values. So at the end you will get 3 0 eigenvalues.
Okay, ma'am. Okay.
Okay. Okay. Any doubt in this?
No.
No doubts?
Can you explain this again, ma'am?
Okay. So we have one properties regarding eigenvalues. If there are identical rows, then the number of 0 eigenvalues will be number of identical rows minus 1. So here this row and this row is identical. Okay. So here is you have how many 0 eigenvalues? 1. 2 minus 1. Then again these three rows are also identical. Okay. So from there also you will get 2 0 eigenvalues. So total you have 3 0 eigenvalues. So total in 5 cross 5 you will get 5 eigenvalues in which 3 are 0. So what we did, we made a equation like this. So now we have two eigenvalues, lambda 1 plus lambda 2, and their summation will be the trace of this matrix, which is 5. So from now you can guess if the summation of two number is 5, so definitely their multiplication will be greater than 5. So from here you can guess there is only one option which is greater than 5. So your answer will be 6.
Okay, ma'am.
Ma'am, the eigenvalues will always be positive only.
That is depends like what properties are there. For some they are positive, they might be positive or negative. Now we will solve one more question.
Ma'am, eigen value can also. So, ma'am, the product might be 2 or 3 also.
Your voice is very low.
Hello?
Yes. I cannot hear you. Please, whatever doubt you have, you can write in the chat box. matrix is also a way, but I don't know how will you make a triangle block out of this matrix. If these elements are also 0, then you can make a triangular block matrix. I will teach you block matrix also, how to calculate eigenvalues when you can convert your matrix in block matrix. But I don't know if we can do that in here. Okay, so consider this is a matrix. Okay, this is a 5 cross 5 matrix, and this matrix A has one real eigenvalue, only one real eigenvalue. Then the value of that real eigenvalue is what? That they are asking. Your options are minus 2.5, 0, 15, 25. Try to solve this question. 15. Okay, Vikas, you are correct.
Hello, ma'am.
Yes.
I have a general question that we are studying about vectors in the vector matrices.
Mm-hmm.
So here you present 5 cross 5 vectors. Means the vector have 5 dimensions or what else? Or if we consider 3 cross 3 matrices, we are finding the eigenvalues. Does the eigenvalues represent a solution of the matrix vectors or what else? I am not getting it.
Okay. So, have you ever, about the stress tensor? Okay, do you know
Yes,
about the
ma'am.
stress tensor matrix?
Yes, yes.
What is it? It is a 3 cross 3 matrix that will tell you stress at a point
Okay.
with respect to 3 direction. 1, 2, 3 you can see. In that, what you look a plane also and you look a stress also. Suppose you are having a cube, you're applying stress in this direction. And what you want to calculate what will the stress in this plane. Suppose this is the plane. Okay. There will be one plane in which this stress will be maximum. That is called as principal plane, right?
Right.
And the value is called principal stress. The same thing is here. When you calculate the eigenvalue of your stress tensor, it will be your principal stress. I'm using this example because we are in mechanical, so you can understand easily.
We are finding critical values. So this.
Okay. Suppose we are getting a matrix. Matrix is suppose it is the dimension. We are taking a 3 cross 3. Why I'm not taking a 5 cross 5 or 6 cross 6? Because it is not easy to imagine. The best way to imagine is 2 cross 2.
Right.
But suppose we are taking a 3 cross 3. So what is the eigenvalue or eigenvectors are showing here? Suppose when you are doing any kind of linear transformation.
Okay.
Like you are stretching, you are rotating or translating. Rotating or translating. So what you are actually doing is you are changing the row and columns. You are interchanging them. That's what you are doing when you are doing changing the direction or you are translating. When you are translating, you are just multiplying by k. So that is why your determinant will be not change.
Okay. Yes, it will multiply by some factor.
Yes. your determinant will not be changed if you interchange the row or columns. Same thing is
Yes.
for eigenvalues and eigenvectors. So what is eigenvalues and eigenvectors are telling here? Suppose you are stretching them. You are stretching in some plane.
Okay.
X plane or Y plane or Z plane. So in what direction you can stretch, so it will be not changed. Its determinant will not be changed. Is called your eigenvector. And how much value you can stretch it, that is called your eigenvalue. Understood?
Okay. Understood, ma'am.
That can you imagine for 5 cross 5?
Ma'am, could you please?
Okay, I got that. Thank you.
Okay.
I could note it down.
15. Correct.
Ma'am,
Yes.
could you please repeat it again that we could note it down?
I'll share you the notes.
Okay.
The answer is 15. Whoever got this answer is right. We will just solve this question. We will solve this question. So our matrix was okay. So firstly, what we'll do, we will write in its characteristic equation. That will be 1 minus lambda 5 4 3 2 2 1 minus lambda 5 4 3 3 2 1 minus lambda 5 4 4 3 2 1 minus lambda 5 5 4 3 2 1 minus lambda 0. Firstly, what we will do, row operation, R1 replaced by R1 plus R2 plus R3 plus R4 plus 5. So if you will do any kind of row operation or column operation, your eigenvalues or eigenvectors will not be changed. Eigenvalues will not be changed. Okay, so we can do the row operation here. So after doing the row operation, the first row will be changed as 15 minus lambda 5 4 3 2 1 minus lambda 5 4 3 1 minus lambda 2 1 minus lambda 5 4 3 2 1 minus lambda 5 4 3 2 1 minus lambda. Okay, from here you can take 15 minus lambda out and one big matrix will be remaining here. So this is your characteristic equation. So what are the eigenvalues? Roots of this equation. So one root will be this also, 15 minus lambda is equals to 2. So from here you can get lambda is equals to 15. So one real root, that was your C option, 15 is correct. Any doubt in this question? Sorry? Okay, I assume no doubt. So do you want to continue or we will meet in next session?
No, we can continue.
Okay.
And we can continue.
So this question is based on analytic approach, right? This is not based on any specific property.
No. Like you can see here what they have given. Sometimes in the question, suppose if you plus every row, the summation will be 15, 15, 15. So that one thing you should think like some relation will with this. At the end you have to do the summation of all the rows. So in question also some kind of trick is there. Okay. So firstly you will just write your characteristic equation, and from there you can get that in one row you can get 15 minus lambda. You could have done that for column also. From there also you can get a common 15 minus lambda. So there was nothing property here. This is a simple question.
Ma'am, can you do from the any other row from like R2 or any other row we can do that from
You can do. Suppose you're doing from R2, you're replacing R2 or R3 or R5. Then here it will become as 15 minus lambda, 15 minus lambda, the whole row. From there also you can get a common 15 minus lambda, and that will be your root. If you don't want to do row operation, you can go for column operation also.
Hello, ma'am.
Yes. Yeah, just give me 1 second.
Ma'am, textbook, any textbook, ma'am, to read?
I think you should solve all the previous equations, like previous
Okay.
question papers, and I will try to provide you other department question also, like other branches question also. At the end of every class, I have all the questions that are being asked in GATE with this topic. So I'll give you the PPT and just solve that 20-30 question of each topic, and then practice any test series if you have taken. I think NPTEL is also providing some test series. Then you can join any test series, and that is more than sufficient for mathematics. Then you can spend your time on technical subjects. Okay.
Learning a concept.
For learning concept,
Yes, ma'am. Methods.
there are some courses on NPTEL, but those are time taking. What I tell you that you just find some notes, like there are few platforms they are providing like made easy notes. One channel I know, this is called Divani IS and Gate. These notes are
Okay,
from
ma'am.
Naveen Yadav. They have provided short notes also and full notes also. So what you do, just give it a reading, and after that you can solve the questions. Just read the notes and solve the question. I think that is enough for you.
Okay,
For
thank you
GATE,
so
that
much.
is enough. The more number of question you will practice, the more type of question you will practice, that will be helpful in GATE. Okay, because they will not ask you very lengthy or very more conceptual based question. They will very gentle question, very easy question. But the thing is, you have to understand what they are asking. If you will get to know what they are asking, then it is very easy to solve that question.
Okay, okay, ma'am.
Madam, this is the
Okay,
second
ma'am.
class, ma'am.
This is the second class. Yes. Okay. After this week, maybe NPTEL will upload that recorded session. So you can get the first session from there. In that session, we completed matrix algebra and linear system equations. We solved all the questions and few tricks that I have to.
Madam, from where we get that class notes, ma'am?
This class notes?
Yes, ma'am.
That I have asked our professor to provide, but they didn't respond us yet. So if they will not upload this on NPTEL portal, Gate portal, then I will share you on a drive link. Okay?
Ma'am, I have a doubt.
Yes.
Actually, there is a confusion between the number of linearly independent solutions of a homogeneous system and number of linearly independent eigenvectors. Like the formula is very similar between the nullity and rank.
Okay. Yeah. You can get confused between linearly independent and linearly independent eigenvectors. Formulas are not that same, but they are similar. So what is your confusion?
Basically, how to understand and remember the formulas.
We see for just vectors, not eigenvectors, for just vectors, for checking if it is linearly independent or dependent, what you have to do, firstly just you would get the determinant. If it's 0, it is dependent. If it's not 0, it is independent. Or if the matrix is 5 cross 5 and 6 cross 6, that finding determinant is time taking, then what you can do, you can calculate the rank. If rank is equals to the n, that is number of columns or number of unknowns, then it is independent. If it is less than n, then it is dependent. Okay? For this. For linearly independent eigenvectors, we have that different formula. That is, firstly, all those things you have to do for this matrix. A minus lambda I. Okay? You have to calculate rank of this. So then, if your free variables or nullity or this is coming 0 or greater than 0, what is the formula? Free variables or number of linearly independent eigenvectors is equals to number of columns minus rank of this matrix. Okay. Now, is there any confusion? Now you can easily remember this also. Right? These things are for just vectors. For calculating, like checking if eigenvectors are linearly independent or dependent, you have to calculate rank of this matrix. Okay? But you can calculate determinant also. Is this again confusing?
Yes, ma'am, it's clear. At the same time, we have linearly independent homogeneous system solutions in system of equations.
Okay.
There we have number of linearly independent solutions of a homogeneous system. Ax equal to 0.
Yes.
I felt that, and the second one, that is a linearly independent eigenvectors, that is very similar because both are homogeneous systems.
But see, when we look for when we consider that if our system is homogeneous or it is non-homogeneous, when we are trying to look what will be the solution of this system, I don't know why is this coming here in the linear independent and dependent vectors. Like when you're solving a system, this is the equation, this is the system. Okay, when we look if for how to solve homogeneous, if you solving homogeneous, your solution will be consistent. Then you calculate rank. If it equal to the order, then it has finite number of solution. Oh, sorry. Then it has one solution. If doesn't have equal to the rank, then it is infinity many solution. Kind of that. So how is that question is coming in homogeneous or non-homogeneous? That I'm not understanding. Actually, I'm not understanding what is your doubt.
And actually, we have independent solutions, right?
Okay.
So probably that is very similar. We have independent solutions in a homogeneous system.
That is solutions, huh? That time we are
That's
making the solutions of the equation. Here we are not touching, we are going for solutions. We are checking the vectors and the values. Like suppose the example I have taken, if you are performing any kind of transformation, so what transformation will not lead to change the values of determinant and other values? Okay, but I will try to understand your doubt and maybe next section I will try to tell. Okay?
Sure.
Okay. Okay. So when we were in our last session, I told you how to use block matrix method and calculate the determinant. Now we will do same for the eigenvalues. How we use this block matrix method and calculate the eigenvalues. So what is this block matrix method? Suppose they are given you this 4 cross 4 matrix. They're asking you to get the eigenvectors or eigenvalues. Okay. So what we do, suppose you are finding that there is a section which is containing only 0. Like we used to did in determinant. When we found our determinant, this kind of section. Like one whole section is 0. So that time what you do, you divide that matrix in 4 parts. Here also, you divide your matrix in 4 parts. Okay. You will divide your matrices in 4 parts. You will write it as A, 0, 0, B. So then your eigenvalues will be the eigenvalues of A and eigenvalues of B. So this is a 2 cross 2 matrix. You will get 2 eigenvalues from here, and this is also a 2 cross 2 matrix, and you will get 2 eigenvalues from here. So your total eigenvalues will be 4 that will get from A and B. Suppose this is this form, this block form. Suppose your matrix is in this form, B 0 0 C or B C 0 D or B C 0 D. Then any kind of these form, then your this portion is 0 or this portion is 0 or both are 0. Your eigenvalues will be the eigenvalues of BC, BD and BD for the respective matrix. Okay. So here if you calculate eigenvalues from this matrix, that will come as, tell me, for A, what will be the eigenvalues? So will come as lambda square minus 4 lambda plus 2 is equals to 0. So our eigenvalues will be 2 plus root 2, 2 minus 2. Then for B also you will calculate eigenvalues. It will come 3 minus lambda, 4 minus lambda is equals to 0. So lambda will be 3 comma 4. So these 4 values will be the eigenvalues of this matrix. Understand this method? Did you understand?
Yeah, we did it on the previous session.
In previous session, what we did, if some matrix which are in this form, or which can be converted in this form or any of these form, then how we will calculate the determinant, that I have shown you. In this, we are saying if this kind of matrix is given, then how we will calculate the eigenvalues. Okay.
Ma'am, where did you get the value of 2 plus root 2 or like that? 2 minus root 2?
Yes.
Oh, go get it.
Actually, what are you asking?
Got it. Actually, eigenvalue 2 plus root 2 and 2 minus root 2. Where did you get?
How did I get that?
Mm-hmm.
See, what I told you, if your matrix is in this form, that if in any corners there are 0, that you can convert your matrix in these any of these forms. So this matrix we can write as A0, 0B. Okay, this will be your A matrix and this will be your B matrix, and this is 0, this is 0. Okay, so the eigenvalue of A you can calculate easily because it is a 2 cross 2 matrix. So what I have did here, I calculated the eigenvalues of this 2 cross 2 matrix. If you will do like 2 minus lambda 1, 2, 2 minus lambda is equals to 0. This will be your characteristic equation for this section, right?
Yes.
So if you will solve this, this equation will come and this eigenvalues are coming. Then for B also you do the same thing and the eigenvalues will become as 3, 4. So the eigenvalues of this matrix will be these two and these two. Understand?
No, I can tell.
Again, suppose they have given you some matrix in which is are having this form. Like you can divide the portion in 4. Suppose this was 6 cross 6 or 8 cross 8, and one portion is complete 0, is null matrix here also, or any of these form like A00B, yeah, B00, same only, B0CD, any of the section below the diagonal is 0, kind of this. If you try to convert this in this form, then your eigenvalues of that matrix will be the eigenvalue of A and eigenvalue of the B. So what I did, I just divided this into 4 parts. This is my block matrix that is in form of A0 and 0B. Okay, so now they are asking to calculate the eigenvalues. So eigenvalues of this whole matrix will be eigenvalue of A and eigenvalue of B. So this matrix is A and this matrix is B. So then I calculated separately eigenvalue for this matrix and then eigenvalue for this matrix.
Yes, ma'am. One node link.
Your voice is not clear. Can you write? Okay, I want you to take screenshots for a few questions. In next session, try to do these questions. Next session, we will, the complex matrix is left. We will try to solve all questions. The question is next session. Just take a screenshot of this question and try to solve this question in next session.
Madam, I have a doubt, madam.
When is next section, ma'am?
Friday only. Today it was 6 to 7. I actually requested them to convert it to 7 to 8. So before joining, please check on the portal if it is 6 to
Other
7 or
subject?
7 to 8.
Other
Yes.
subject when?
Other subject.
No, other subject. Yes, ma'am.
Okay. On Monday, uh, one of my friend, he is teaching thermo. On Tuesday, one person is teaching Tom. On Wednesday, I need to mute him. Okay, number 5. Wednesday, I think this is some manufacturing kind of subject. Thursday, there will be no session. Friday, I'm teaching maths. Saturday, also, one session is there, and I think he started calculus. So, next class will be calculus also. You can read calculus there. I will cover linear algebra, then we will start differential equations, and then I will teach one more chapter of mathematics, and then we will start industrial. So as fast as we will solve the question, we will finish this and we will start our practice. Okay.
Saturday time.
Saturday, I think it's 4 to 5. You check on gate portal now. I'll show you how to.
Madam, those timings, ma'am, class timings would be 6 to 7 is not, 7 to 8 will not possible. Ma'am.
Okay. You can see here. These are the timings and these are the sessions. Okay. What were you saying?
Notes, ma'am.
Sorry?
Ma'am, notes, ma'am.
Okay, madam.
Hello, ma'am.
Yes.
This Wednesday class and 4 to 5 is there. No, ma'am, is kindly request to them shift 7 to 8. It will not possible, ma'am.
Yeah, 4 to 5 is odd timing only. So we all requested to change our timings. You can also tell the person to change his timings. I have requested for 7 to 8. So next
Yes,
session
ma'am.
I will take from 7 to
7
8.
is a good time, and 7 to 8 is always free and will be able to attend class.
Okay, what is your preferable timings? All of you, tell me.
Ma'am.
Yes.
Ma'am, Saturday there is fluid mechanics.
Fluid mechanics, he haven't started. He is teaching calculus. After calculus, I guess he will start fluid mechanics. You can ask him on during the session.
Yes, ma'am.
Okay, ma'am.
Okay, I actually requested for 7 to 8. Maybe from next session, it will be 7 to 8. Because last session, most of you requested for 7 to 8. So I requested them if my session can be changed to 7 to 8. Okay. Yeah, I've already requested. Maybe from next week, it will be 7 to 8.
Okay.
Ma'am,
if it can be extended, it will be better, ma'am.
Like officially, it cannot be extended, but it depends on us. I can teach you for 2 hours or 2.5 hours. Officially, we asked, but they cannot officially change it to 2 hours or 3 hours.
Madam, each class duration is 1 hour or 1.5 hour, madam?
It is 1 hour, but most of them are taking 2 hours or 1.5 hours.
Madam, in the previous, madam,
Yes.
in the previous slide you said about the block matrices, no, madam?
Yes.
In the type ABC, we can neglect C matrix, madam.
Yes, you have to just consider the diagonal ones. Okay.
Diagonal matrices only.
Yes, diagonal matrix.
Okay, madam.
Okay, like today also I have sent lots of questions also, but we don't have time for that. So we'll do the question in next session. Yes.
Can I share the today's class, ma'am?
You want recording or you want PPT?
Ma'am, PDF.
Okay. Video will be uploaded on the portal.
Ma'am, video, ma'am. PPT, ma'am.
not be uploaded on portal. So one thing I can do, I can share on my Google Drive. But
Yes, ma'am.
till now I didn't get the permission, so I didn't send. So you just keep this Google Drive with you.
Yes, ma'am.
Maybe before next session I will upload. Okay? Keep checking.
Yes, ma'am.
Hello, ma'am.
Yes?
Hello, ma'am. Ma'am, YouTube channel name once again tell ma'am for practice.
Okay, it was Divani Gate and IS.
Diwan.
You can get the free notes also.
Gate
Notes
है
also. Their notes are from MEDZ only, I guess.
Ma'am, RS is not started, ma'am.
Gate ma'am.
Sorry?
Ma'am?
Yes.
Ma'am, RSC
Refrigeration is not started yet because we are just 5 people. So firstly we will complete one subject, then we will start other. So till now thermodynamics, Tom, manufacturing, mathematics is started. Tom is on Tuesday.
Ma'am, Tom when started, ma'am?
2 sessions are already done.
Ma'am, I am not there, ma'am.
It is on Tuesday.
Yes, ma'am.
Okay, you can get the recording.
Thank you, ma'am.
All we are doing is just teaching concepts and we are just solving the questions. Yeah, you can leave.
Excuse me, ma'am. One down.
Yes.
Ma'am, questions.
Ma'am, for engineering sciences,
Okay.
is there any extra questions we need to practice? Because the level of questions is a bit high, I feel. So.
Can you repeat, please?
Ma'am, are you able to hear me?
Yes.
For engineering sciences, XE the paper,
Mm-hmm.
we have maths compulsory, right?
Okay.
For that, I think there are certain topics extra, and the level of question difficulty is a bit high, like than ME. So, is there anything extra we can practice?
If you want to do theoretical question also, like big questions, I can give you the questions. And we can solve also. That much I can do. I can show you the question, what kind of question they are asking, and we can solve in the class. But that will take time.
Okay. But the PYQs are sufficient.
Yeah, previous year is sufficient.
Ma'am, I have one doubt, ma'am.
Yes, please.
How to access, ma'am, previous videos, previous lecture videos?
Till now I haven't uploaded anything. I send you one Google Drive. Like, I think before the next session, it will be available on the portal itself. Okay. If they will not upload on the portal, then you can. I will upload on my Google Drive, and you can exit it from there.
Okay, ma'am. Thank you.
Yes.
Ma'am, what are the questions you were asking to take the screenshot?
Yes. Please take the screenshot of this question and try to solve. We will discuss in the next session. Okay? Second one.
Done, ma'am.
Third. This kind
Done.
of question we already solved. Try to solve this question. This is a very nice question.
Yes, ma'am.
Done, ma'am.
Hello, ma'am.
Ma'am, Saturday time is 4 to 5, ma'am.
Saturday also is 4 to 5.
Hello, ma'am.
Yes.
I have a general doubt, ma'am. Can I ask?
Sure.
For this course only those who are appearing for on February GATE is beneficial, ma'am, or those who studying currently second year or third year also?
See, I'm telling you very basics also. And
Yes, sir.
this is
Yes, ma'am.
same for or others also. So it depends on you. If you are understanding, you can understand here. If you are feeling this is beneficial for second year or third year also, you can stay because we are teaching from scratch. If you have any doubts, you can ask. I will teach you from very basic.
Yeah.
Okay. The main motto of the sessions is to solve the questions, all gate questions. But before that, we